So practical skills. It's not really just one practical, it's multiple. And it's really just tests to learn for ions. Sorry, not for ions, for primary, secondary, tertiary alcohols, all of that, aldehyde, ketones, carboxylic acids, all of that kind of stuff. So this is an organic analysis. So describe how to use acidified potassium dichromate to decide whether it's primary, secondary, or tertiary alcohol. First things first, you want to add 10 drops of the alcohol to 2 centimeters cubed of acidified potassium dichromate in a test tube. Once we've added 10 drops of the alcohol to 2 centimeters cubed of acidified potassium dichromate in a test tube, you want to warm mixture gently in a hot water bath or electric heater. And if it's a primary alcohol, the orange solution slowly starts to turn green as an aldehyde forms. And if it's a secondary alcohol, the orange solution slowly turns green as ketone forms. And if it's a tertiary, nothing happens. The problem with this test is that obviously that both of these have the same observation. The aldehyde forms, the orange solution slowly turns green. Ketone forms, orange solution slowly turns green. So why does the color change happen? Well, the orange dichromate 6 ion, Cr2O72- is being reduced to a green chromium 3 ion, Cr3+. Orange dichromate 6 ion, Cr2O72- being reduced to a green chromium 3 ion, Cr3+. So how do you find out which product we started with? Because both of these, primary and secondary, orange solution slowly turns green as aldehyde forms, orange solution slowly turns green as ketones form once you added 10 drops of alcohol to 2 centimeters cubed of acidified potassium dichromate in a test tube and then warm mixture gently in a hot water bath. So if we want to find out which product we started with, add excess alcohol to 2 centimeters cubed of acidified potassium dichromate in a round bottomed flask. Once you've added excess alcohol to 2 centimeters cubed of acidified potassium dichromate in a round bottom flask, you want to set up the flask as distillation apparatus, which I will go through apparatuses and like the drawings of them in a separate video. And then we want to gently heat the flask, and what will happen is, when we added excess alcohol to 2 centimeters cubed of acidified potassium dichromate in round bottom flask, we set up flask as distillation apparatus, we gently heat flask, alcohol will be oxidized and product distilled immediately, and therefore we can collect the product. State three main regions to distinguish between aldehydes / ketones: Fehling solution, Benedict solution, and Tollens region. So describe how to use Fehling's and Benedict's. Describe how to use Fehling's and Benedict's solution to distinguish between aldehyde and ketone. You want to add 2 centimeters cubed of Fehling's / Benedict solution to a test tube. You want to add 5 drops of the aldehyde / ketone to a test tube, and you want to place in a hot water bath, gently warm the mixture, and then leave it to cool. And then if it's an aldehyde, blue solution will give a brick red precipitate. However, if it's a ketone, nothing will happen. Describe how to make Tollens reagent. So we want to put 2 centimeters cubed of 0.10 mole dm cubed of silver nitrate solution in the test tube. So describe how to make Tollens reagent. Put 2 centimeters cubed of 0.10 mole dm cube silver nitrate solution in a test tube. You want to add a few drops of dilute NaOH, dilute sodium hydroxide. And what happens when we add the few drops of dilute NaOH, sodium hydroxide, is that a light brown precipitate forms. Then we want to add drops of dilute ammonia until the brown precipitate dissolves completely. So that's how you make Tollens reagent. Put 2 centimeters cubed of 0.10 mole per dm minus cubed of silver nitrate solution in a test tube. You want to add a few drops of NaOH, sodium hydroxide. A light brown precipitate should form. Of dilute NaOH, add a few drops of dilute NaOH, sodium hydroxide. A light brown precipitate should form. And then add drops of dilute ammonia until the brown precipitate completely dissolves completely. Describe how to use Tollens reagent to distinguish between aldehyde / ketone. I probably should have written to distinguish, but you get the point, hopefully. You want to place a test tube in a hot water bath. We want to add the 10 drops of the aldehyde slash ketone, whichever one we're trying to find. So place test tube in a hot water bath, add 10 drops of aldehyde slash ketone. That's it. And if it's an aldehyde, a silver mirror forms on the walls of the test tube. And if it's a ketone, nothing. Nothing happens, no color change, no nothing. Nothing. So why do you get a silver mirror when you place a test tube in a hot water bath? You add 10 drops of aldehyde. And then a silver mirror forms on walls of test tube. Why do you get a silver mirror? Because the aldehyde reduces the Ag plus ions. Aldehyde reduces the Ag plus ions to silver atoms. Describe how to use sodium carbonate test for carboxylic acids. We're going to add 2 centimeters cube of solution that we want in the test tube. We're going to add 1 small spatula of solid sodium carbonate in the test tube to test tube. And then if the solution begins to fizz, we want to bubble the gas through lime water in a second test tube. And if it's a carboxylic acid, a solution will begin to fizz. CO2 gas will be produced will turn the lime water cloudy. And if it's not carboxylic acid, nothing happens. So describe how to use sodium carbonate to test for carboxylic acid. You want to add 2 centimeters cube of solution we want in the test tube. We're going to add one small spatula of solid sodium carbonate to the same test tube. And then if the solution begins to fizz, we want to bubble the gas produced, the CO2 gas produced through lime water in a second test tube. And if it's a carboxylic acid, once the solution begins to fizz, bubble the gas through lime water and it will turn the lime water cloudy. CO2 produced will turn lime water cloudy. If it's not carboxylic acid, nothing happens. And one more key thing about this test of sodium carbonate test for carboxylic acids is that it will always produce a positive reagent with any acid. So you have to make sure that one of the products is that when you're distinguishing between organic compounds, that one of the organic compounds is actually carboxylic acid. You have to be sure that.